Good afternoon to all of you. I am thankful to the organizer for inviting me to this important training program on capacity building and third party audit under the program of National Clean Air. Today I am going to present one of the control option for traffic intersections to capture the emissions from the near field sources, that is vehicles. We all know that we have a problem of high air pollution in urban areas especially. It is not the problem of our country, it is a worldwide issues. Only there is a variation in the severity which generate a need of an efficient and effective urban air quality management plan to improve the urban air quality. We all know that there are many sources which are already identified and quantified and responsible for the poor air quality, but still we need to find out some of the uncontrolled sources and unaccounted sources, because whatever the sources we have identified, government is working on that and trying to control the emissions. But as we go ahead, there is a high growth in the activity and source emission activities which always take a lead in compared to the control options we have implemented in the uh, to reduce the emissions. There is one more reason for the high air pollution issues are the geographic locations and meteorologies. So these two are the important parameters which inhibit the dispersion of the pollutants and mm, make conditions to so that it's build up our particular regions. Again, it is also very important to understand the scale of the problem, and once we have its boundary of the problem, we can accordingly act. So again, like for example, during the post monsoon season, we have high issues of regional air pollution in along the Indo-Gangetic Plain. But along with that, there is a problem of high local variations within the city, which we generally call the urban hotspot. And these urban hotspots are responsible for elevating the average level of the city, average pollution level of the city, which also need to be tackled, because as per the most of city air quality is represented through the AQI, air quality index level, and as per the guidelines of the national air quality index, a maximum or highest AQI value of the city out of all the available stations is representative of the city air quality, represent the city air quality. So as we are going to talk in this the source specific control. So before to go on the main topic, there is need to understand the heterogeneity in the sources in the urban areas. We have numerous sources which is already identified and quantified, but these sources have high variations. For example, motorized traffic. There's a high diurnal variations at a particular location, and if we compare the city, there is a some critical areas where the traffic density is very high. So with this source we have a high diurnal problem and high spatial variations problem. All these heterogeneity is creating a problem in the implementation of the management strategies. Again, industries, if you talk, there is a location specific issue. Domestic, it's almost homogeneous in the terms of spatial variations, but there is a diurnal variations because we generally used to cook only in the morning, lunch, and dinner times. Open biomass burning, it is again not accounted properly as well as, and it is there is no proper information on the spatial distribution as well as the temporal distribution of the source. DG set, again spatial variation, the number of DG sets always high in the commercial or industrial locations compared to residential one. Construction activities, location specific problem and only for short terms. Agriculture residue burning in the surrounding rural areas, location specific and short term. Resuspension of the road dust is one of the important source and key source for the urban air quality problem, and it is especially in our Indian cities, it is one of the dominant source of particulate matter. Transport of dust from surrounding area is also one of the issues which cannot be controlled. It is a natural phenomena and need to be think considering this is a in the side, or there is need to be develop some green belt so that we can create a kind of barrier in which disturbs its transport or its flow from the city. Definitely in the day before yesterday presentation by Dr. S.K. Goyal, you have seen these two pictures where he explained about the air pollution hotspot, its identification, which we have developed some of the criteria by analyzing the air quality data, especially the PM 2.5 of all 38 stations by analyzing their frequency of accidents of the standards, scale of accidents, and consistency in the accidents. So all that things is very necessary to understand the heterogeneity in the sources. Even though the regulatory agencies also notified 13 areas as air pollution hotspots in Delhi, and these 13 numbers is varying year to year. There is need to proper analyze the data which should cover season specific as well as spatially activity. Air quality problems again varies as season change because we have some season specific emission activities, and again the poor meteorology especially during the post monsoon and winter seasons creating a problem in Indian cities. Need to capture all these unremarkable pollutants that are not easily detected and quantified. All these variations and heterogeneities generate the need of preparing activity mapping and their role in local emissions and air quality around the monitoring station as well as other identified hotspots by some other modeling or emissions based data. Understanding the triggers points that can be controlled and the effectivity of the actions can be checked. Before to start work on the control actions, we have done a review of literature on the air purification processes, where we found that there are numerous scientific processes available which are used by researchers to develop the air pollution control devices, and the application of these devices tested validated in ambient as well as source specific pollutions. So we also observed that each a control device is not only depend on a single scientific process, but in combination. So where the physical filtration is one of the common approach, the researcher has been adopted along with these four scientific process like biofiltration, ionizations, photocatalytic oxidations, and phytoremediations. All these scientific process have some kind of merits as well as demerits, which need to be properly judged and review before applying in controlling the pollutions at the particular locations. And this is the list of air purification devices implemented and tested in different countries or different areas of the globe. Some of the name I can read here is City Tree, which is based on the phytoremediations or what calls a biofiltration process, can be efficient in removing the pollutants like PM and NOx. Efficiency also mentioned in the literatures by the researchers. Again, Smoke Tower China, BioUrban version 2. Some of the literatures is taken from the website of the developer, and some are taken from the research papers. However, we found that there is no proper scientific data available which claims that these techniques or these devices are performing efficiently for the purpose they are designed. Biofiltration, photocatalytic oxidation, and phytoremediations are very effective for gaseous pollutants such as sulfur dioxide, nitrogen oxides, VOCs. However, filtration and ionizations are generally used for particulate matter. Some of the prototypes are developed by combining 2-3 scientific processes such as filtration plus ionization, filtration plus photocatalytic oxidations, which is capable in removing particulate as well as VOCs and CO. As I said, limited information is available which scientifically prove that these devices are working efficiently. You can see some of the pictures which showing very beautiful design of the purification system, and along with that two are from our Indian already in placed in Indian cities, especially in Delhi. So here I am coming to the main topic of today lecture, which is one of the device or one of the techniques which we have tested, or we can say which we have designed, developed, and tested in lab as well as in the field for particulate matter removal. So we called it a wind augmentation purifying unit, called in short WAYU. It is developed with the support from Department of Science and Technology and tested in the field at Delhi with the support of CPCB. It is a small scale intervention and suitable only for microenvironment. Specifically designed with the aim to capture the nearby sources such as emissions from traffic at intersection and roundabout. The three pictures is showing the base model in the left side, which is tested and started this device in Mumbai. After that, these two devices which having a low uh, base so that it can easily accommodate at the traffic intersection or medians where space is one of the major constraints. Basically, the device works on two principles: active pollutants removal through the filtrations and photocatalytic oxidations, and second, the device release the clean air with some force which dilutes the ambient air around the devices. And we all know that the dilutions of any media is reduce the pollutants. The operational, if I talk about the device specification, the operational cost of the device comprising electricity cost, human resource cost for filter replacement, transport cost of filter change, and maintenance cost varies based on the total number of devices are in operation, number of site, distance between location. This is the most of the questions we faced in the last 2-3 years. What is the operation cost? What's the capital cost? So if I talk about the operational cost, when we tested it in Delhi at 5 sites for 15 hours per day operations, so considering all the above cost, it comes about 3500 rupees per month per device. The noise level generates from this device, or the because it says a mechanical motor is installed in both the device, and it is in the range of 50 to 55 dB and 60 to 65 dB respectively. However, all these devices are recommended to place in the ambient near to the traffic source, so that the so to capture more particulates, and found that the noise generated from the vehicular movements predominates the noise generated by the device. These are the specification of the device, which explain about the dimensions, weight, flow rate, power requirement, filter type, foundation space requirement, because all these are the questions which generally the sponsor or that regulators asked, because all these the challenges we faced when we plan to install such devices. We use this methodology which is explained in this flowchart to adopt to test the devices at field. So basically the first important challenge was the selection of the site, and the criteria is it's a traffic location, also polluted, and should have a proper space to install that. We discuss in this project for the site selection with the traffic police, which have database of the high traffic congestion areas, and the availability of space, and there is only one more problem, is the theft of the machines. Then after selecting that site with the consultation of pollution control board as well as traffic pollution control traffic police, we have installed these devices, operate each device for 15 hours considering morning and evening traffic peak hours. Then each machines has filters, physical filters, which is known fabric filters, which are easily washable and reusable. So we have done the filter change of each device, and the collected filters will has been taken in the lab and cleaned using vacuum cleaners, and whatever the dust we have collected, we stored it properly. As a R&D institute, we did some particle size distribution of the collected PM and chemical characterizations to further quantify the sources using receptor models or other source apportionment techniques which we generally used in for source contribution analysis. We also done the monitoring of particulate matter at inlet and outlet of each design at all 5 sites, and then compare the performance of the machines by comparing the inlet and outlet concentration of different size particles. This is the pictorial view of the site where we have installed all these devices, and you can easily clearly see the intensity of the traffic at these locations. These locations are Wazirpur Chowk, ITO intersections, Shadipur metro stations, Anand Vihar, and Bikaji Gama place. We reviewed almost 20 sites and selected all these 5 because they have a they are highly polluted also, as Dr. Goel explained in the yesterday day before slides, where he found some of the hotspot, and Wazirpur, Shadipur, Anand Vihar are the 3 identified hotspots in this in his analysis. The table is explaining about the traffic characteristics and road characteristics of each site. Also, we done the monitoring at all these 5 sites, and you can see that the level of pollutions at these site or near at the nearby CAQMS stations are very high. The slide is explaining about the performance in collection of particulate matter, mass, and during the operations of almost 54 sites for operation of 120,000 operating hours, we collected 34.1 kg of particulate matter. Then it is also important that at what rate the PM mass is collected, and we found that in every 1 meter cube of air, machine is able to collect the mass of 267 microgram during winter and post monsoon, and 180 microgram during summer. Again, we found that the rate of collections of mass by the device is vary site to site, as it is directly proportional to the pollution load at that site. We also calculated the clean air delivery rate, and which again varied between site to site and season to season. You can see clearly the color of the fresh filters as well as the exposed filter after 1 week, and you can easily see the color combinations, how it is get exposed and due to the high air pollution load. Then there is a questions comes that what's the frequency of filter change? It should be 1 week, 10 days, or 15 days, or once in a month. For that analysis, we have done some analysis by monitoring the pressure drop at 2 sites during the post monsoon season, which is critical and well known for the high air pollution in Delhi NCR. And we found that after 3rd day at Anand Vihar and 5th day at ITO, the pressure has been dropped 50% of their design capacity, and we freeze that as a cutoff point to change the filters. So during this month or this season, we have changed the filter on every 3rd day at Anand Vihar and every 5th day at ITO. However, during the summer, as the pollution level reduced, we have changed the filter on weekly basis. Again, it is also very important what size of particle are being collected by the device on the filter papers. So for that, we have done the particle size distribution analysis of the collected dust, which indicates that size distribution pattern of collected dust at ITO is different than other 4 sites. You can also easily see that uh, in this graph. Again, there is a huge difference by all the devices. and that particle size distribution of PM 2.5 sorry, or the concentration of or mass of the PM 2.5 is comparatively very less compared to PM 10, which is almost 50%. However, for PM 2.5 it is only 10 or to 12%. We also check the performance of the uh, device with respect to PM10 concentration at the nearby continuous ambient air quality station, and we found that mass collection rate by a device is directly proportional to the pollution load or pollutant concentration at the CAQMS. You can see in both the pictures where we have compared the PM collection rate at Anand Vihar and ITO, and you can see pattern are more or less matched, which indicate that the device perform as accordingly as the pollution load varies. When we compare the inlet and outlet PM concentration, we found that the device performed differently at different sites, and also the capacity of the device also affect its performance. Overall, the device for the PM 2.5 found in the range of 20 to 25%. However, in case of PM10, it varies 34 to 49% in the overall scenario. We also put an efforts to evaluate the zone of influence of the device and monitor the PM10 concentration at different distance from the device in a calm or in a normal condition and at traffic intersections, and we found that it is effective up to 15 meter from the machines. However, we are still need to be do more experiment to define this zone more accurately, and this is only based on the 4 experiments we done. So if overall I summarized, the PM collection rate per hour varied from site to site by this device, and also capacity. Presently we have two design with a different capacity or flow rate, that is 1250 meter cube per hour or 2500 meter cube per hour. The study recommend that there is a need to scale up this technology with high throughput to enhance the zone of influence. The filter materials need to be improved so that efficiency of removal of an ultrafine and finer particle can be improved, because presently it is only up to 19 to 25%. Operation and maintenance of device in the field are one of the major challenges, especially protection from rain, which can be upgraded through automation of the device by installing some of the sensors which detect the rain, electric short circuit and all, and can be recorded properly. There is need some more automation in the device so that the operations can be controlled or checked at remotely on the desktop. Especially the device can be very useful for small areas, and can be effective in controlling the pollution at around the device in their zone of influence. So in the last, I would like to say that along with the regional and national scale problem, we need to be focused more on the local air quality management plan. Need to introduce the techniques, control options at small scale, and implement at the site to control the emission. Most effective approach to deal with the high tempo spatial variations. There is need to be develop this such kind of effective approach, and efforts should be made so that we can be able to convert the hotspot area into non-hotspot area. In other countries, there is some approach or some technique or management strategy is already applicable and also got some success in achieving the targets. Some of the examples are there, which need to be judiciously or customized approach of uh, these management strategies can be adopted and implemented at ground so that we can reduce the number of hotspots within a city. So guys, that's all from my side. I'm again thank you to the organizers for inviting me to this lecture. I'm happy to be answer the questions if you have. Thank you.